Hi, so what we have here, we're going to solve the following quadratic equation. Now, generally, we would solve this equation by using the square root method. In other words, we would take the square root on both sides to get rid of the square on the left-hand side. However, I have a few questions that pertain to, hey, is there another way to do this? Why, of course there is. You can always use the quadratic formula on these problems. However, the issue is when you're doing the quadratic formula, the numbers can get really complicated and really, really big. So that is something you always want to look out for whenever you're doing problems like these. All right. So if you want to do it using the quadratic formula way, well, we have to expand this. We have to FOIL the 7x plus 8 squared into a quadratic or standard form. Okay, so if we FOIL the 7x plus 8, well, minus the little steps in between, you would, excuse me, you would get a 49x squared plus 112x plus 64 equals 48. Okay, now that's just FOILed. Okay, now to get it as a quadratic equation, we have to have the equation set equal to 0 because that's standard form of any quadratic equation. So we're going to subtract the 48 on both sides. And when we subtract 48 on both sides, we would get 49x squared plus 112x plus 16 equals 0. All right, so now we have an equation that is in standard form, and it's a quadratic equation, so we can either use quadratic formula, complete the square, factoring if possible, all that kind of stuff. So we have a lot of methods to choose from. However, the most popular one is using the quadratic formula, because we know the quadratic formula always works. So we want to list out our A's, our B's, and our C's. So your A is 49. Your B is 112, and your C is 16. So now we're just going to go ahead and plug it into the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a, and that would be x equals right there. Okay, so the quadratic formula. All right, so when we plug and check into the formula, we have x equals negative 112 plus or minus the square root of 112 squared minus 4 times 49 times 16 all over 2 times 49. So you see how these numbers are going to get pretty large. So let's keep on working. So we got negative 112 plus or minus. Now, the stuff on the inside of the square root. 112 squared, well, that gets us 12,544. And then negative 4 times 49 times 16. That's a minus, or a negative, 3,136. All over 2 times 49, 98. Always got to make sure. Apologize for that. I had a little malfunction on my tablet. All right. So a negative 112 plus or minus the square root of these two numbers being subtracted. So 12,544 minus 3,136. Well, that gets us the square root of 9,408 over 98. All right. Now, the hard part about the quadratic formula, reducing this square root. Most of your math instructors would want you to keep it as a squared form, not as a decimal, okay? So you're going to have to go through the list of perfect squares and figure out which one actually works. Okay? So if you go through the list of perfect squares, okay, it's going to take you a while to actually go ahead and find it and figure it out. It will be. You can also start dividing 9408 by 1, by 2, by 3, by 4, and so on and so forth. And start figuring it out from there. So I'm going to kind of bring it out over here. And from doing those calculations, it turns out, however, that 9408 is actually, it can be broken up into the square root of 3,000 Okay, there we go. 3,136 and the square root of 3. Basically, what I'm trying to say, though, 9408 can be broken up into 3,136 and 3. So if you multiply 3,136 times 3, you get 9,408. Now, here's the cool part. The square root of 3136 is 56. So this is 56 right here. And the square root of 3, you can't break that up any further. So that would just be the square root of 3. So now we're going to take this 56 times the square root of 3, and we're going to put that in place of this square root of 9408. So that would be negative 112 plus or minus 56 square root of 3 all over 98. All right. So far, that's what we're looking at. Now, we have to take into account, we got to start reducing stuff. We have to look at this number, the 112, the 56, and the 98, and see if we can reduce those three numbers. Well, ironically, those numbers are all even numbers. So at the very least, they're divisible by 2. So you can keep dividing each one of them by 2 if you want. You could also see if you can divide them by bigger numbers. Well, I tried doing 4, and 4 wouldn't work because of the 98. So let's keep dividing them by 2. Let's see where we go from there. So this would be equals 112 divided by 2. Well, that gets you 56. Plus or minus 56 divided by 2. Well, that gets you, it's early, I have not had my coffee yet, 28. Square root of 3. All over 98 divided by 2. Well, that gets you 49. Now, here's the weird part. 56, 28, and 49, they're not all even numbers, so they can't be divisible by 2. They're not divisible by 3, not by 4, not by 5, not by 6. Wait a second. They're divisible by 7 if you remember your times tables. So 56, 28, and 49 are all reducible by 7. So we can reduce this even further. So 56 divided by 7, well, that gets you a negative 8. 28 divided by 7, that gets you a 4. And then 49 divided by 7, well, that gets you a 7. So your final answers, because you can't reduce these any further because the 7 is a prime number. Nothing else will go into 7. So your final answers can actually be negative 8 plus 4 square root of 3 all over 7 and negative 8 minus 4 square root of 3 all over 7. And that is actually the same answer you would get if you were to do the square root method at the very top of the equation, at the very beginning. So as always, let me know if you have any questions of any kind. This is a different way to go about solving this type of problem, but regardless, though, we still ended up with the same answer.